So for today, our main goal is to have a recall or review on the terminologies about statistics. Okay. So we will have a review of descriptive statistics. Okay, so these are the terminologies. So we do have population, refers to a large collection of objects, persons, places, or things. So when we say population, refers to a large collection of objects. Okay? When we say sample, it's a small portion or a part of a population. It could define as a subgroup, subset, or a representative of a population. Parameter, it's any value obtained from a population and usually referred to as a true or actual value if we're talking about population. A statistic, it's a value obtained from a sample or an estimate of a parameter. Okay, so these are the terminologies that we need to familiarize. I think you're familiar with this one. Okay, we're just recalling. Next is data. Data are facts, okay, facts or set of information or observation under study. Okay, so when we say data, these are facts or set of information. Okay. Next, qualitative data and then quantitative data. Data can be classified into two. So we do have qualitative and then quantitative. The question is, Miss, how do you differentiate the two? Okay, data can be classified as qualitative and quantitative. Okay, when we say qualitative, from the word itself, quality, and then quantitative from the word itself, quantity. Okay, so qualitative or quantity are data that are categorical. Quantitative data are data that are numerical in nature. That's why we call it quantity, meaning numbers. But the question is, Miss, how do we apply that in real life situation? Okay, how do you differentiate qualitative and then quantitative? Anyone? How do you differentiate the two? When we say quality, you're referring to the data. Yes, my dear. Okay, very good. Okay, so when we say qualitative data, these are categorical. Quantitative data, these are more on numbers. So let's say, for example, you need to come up with your research. Okay, so when we say qualitative data, how do you differentiate that? So more or less, when we say qualitative, you're doing such as interview, observation. Okay, so that is qualitative. Ano ba example ng qualitative? Let's say, for example, you want to the data type that consists of descriptive statements. So that is qualitative. But when we say quantitative, data type that can be measured. Okay? Yung data can be measured, so that is quantitative. From the word is quantity, numbers. Okay? So how do you differentiate? How do you differentiate the two? For example, if you're using interviews, so that is under qualitative. Because you need to collect data, the type of data that you need to collect is more on descriptive statement. Okay? But what about quantitative? You collect the data based on surveys. Okay? Based on surveys. So that is quantitative. Okay? You get the point? You get the difference between the two? Okay? You collect using surveys. So that is quantitative. Qualitative, if you're doing such an interviews, so that is qualitative. Okay? That is qualitative. Next, what about variable? When we say variable, is a characteristic or property of a population or sample which makes the members different from each other. Okay, so more or less, our discussion for today is more on terminologies. Okay, there's no actual computation, so more on terminologies. Okay, next, what about discrete? When we say discrete variable, is one that can assume or a finite number of values. It can be counted. Discrete. Okay, it's a finite. When we say continuous, is one that can assume infinite values within a specified interval. Okay, infinite values. Discrete, finite, continuous, infinite values. Dependent variable is a variable which is affected by another variable. Okay, dependent variable is a variable which is affected by another variable. Independent variable is one which affects or influences the independent variable. In short, it can stand alone. Okay, that's what we call it, independent variable. Okay, independent variable is one which affects or influences the dependent variable. Okay. Constant, it's a property or characteristic of a population or sample which makes the members of the group similar to each other. So constant, again, it's a property or characteristics of a population or sample which makes the members of the group similar to each other. Okay. Let's proceed now in how do we compute or solve descriptive statistics. Okay. How do we after we collect data, how do we compute it under the descriptive statistics? So we need to apply different measures. Okay, so the first one is measures of central tendency. Okay? Measures of central tendency. So what are the terms? So under the measure of central tendency, we do have a statistic. It's a characteristic or measures obtained by using the data values from the sample. It's a characteristic or measure obtained by using the data values from the sample. Okay? Parameter, it's a characteristic or measure obtained by using the data values from a specific population. So if the given is population, so the value, the data values that we have, we call it parameter. But if the given is a sample, the data values, we call it a statistic. Okay? So measures of central tendency. So what is measure of central tendency? A value that represents a typical or central entry of a data set. Okay? In short, where is the center of that particular data? Okay? A value that represents a typical or central entry of a data set. So how do we measure a central tendency? Okay? Most common measures of central tendency, we do have mean, median, and mode. Okay? Mean, median, mode. I think you're familiar with this three measures. What do you mean by mean? What do you mean by mean? What is mean? Average. Okay, very good. Average. What about median? From the word itself, median. Okay. Middle value or the midpoint. What about mode? Okay, the most frequent. Okay, the most frequent in the given data. Okay, so let's start with the first one, mean. The mean is defined to be the sum of the data values. Okay, the mean is defined to be the sum of the data values divided by the total number of values. So that's how we solve for the mean. The mean is defined to be the sum of data values divided by the total number of values. We will compute two means, one for the sample and one for the finite population of values. Okay. So mean, the sum of all data entries divided by the number of entries. So we do have population mean, mu is equal to the summation of x over n. If the given data is a population, that's how we solve for the mean. Mu, okay, using the symbol mu, is equal to summation of x over n. For the sample, we're using the symbol x bar. Okay, sample mean, x bar is equal to the summation of x over small n. Okay, when we say small n, you're referring to the size of the population. I mean, the size of the sample. Big capital N, you're referring to the size of the population. So that's the difference between the two, population mean and the sample mean. Okay. So for example, the ages and weeks of a random sample of 6 kittens at an animal shelter are 3, 8, 5, 12, 14, and 12. Find the average age of this sample. So in short, the given problem is a sample. So if you say sample, how do we solve for the mean? Okay, how do you know it's sample? Because it says there, the ages and weeks of a random sample. So obviously, the problem deals with sample. So how do we solve for the mean if the given problem deals with sample? So sample mean is equal to x bar is equal to the summation of x over n. Okay, we're using the sample mean because according to the problem, the ages and weeks of a random sample. Okay, there's the word sample. So more or less, the problem deals with sample. Okay, so summation of x over n, small n. When we say small n, you're referring to the size of the sample. Okay, how many? So there are 6 kittens. So you need to add everything and then divide it by 6. So you do have 9 weeks. So that's the average week. Okay, so that's the average week. Okay, age of the average age of the 6 kittens, which is 9 weeks. Okay. Next, a small company consists of the owner, the manager, salesperson, and 2 technicians. The salaries are listed. So we do have $50,000, $20,000, $12,000, $9,000, $9,000 respectively. Assume that this is the population, okay? Then the population mean will be mu is equal to the summation of x over n. So we're using the capital N if the problem deals with population. Okay, if the problem deals with the population. So add everything, add all the given data entries, and then divide it by the number of data that we have, which is 5. So the average salaries, okay, the average salary will be 20,000. So that's the average salary, okay, 20,000. What about median? You said that when we say median, you're referring to the midpoint or the middle value, okay? The value that lies in the middle of the data when the data set is arranged in order from lowest to highest, okay? Measure the center of an ordered data set by dividing it into 2 equal parts. A sample mean is often referred to as if the data set has odd number of entries, median is the middle data entry. If the given data entry is an odd number, okay? Even number of entries, the median is the mean of the two middle data entries, okay? If the given number is even, okay, how do we look for the median? To look for the median is the average of the middle numbers, of the two middle numbers, okay? So that's the median. So for example, odd number of entries, median is the middle data entry. So let's say 2, 5, 6, 11, 13. Okay, how many entries that we have? How many data entries do we have? 2, 5, 6, 11, 13. How many data entries do we have? Okay, 5. So your median will be what? Okay, 6. Okay, so that is the middle number. Okay, next, even number of entries, median is the mean of the two middle data entries. Okay, so 2, 5, 6, 7, 11, 13. So there are two numbers in the middle, and that will be 6 and 7. Okay, 6 and 7. So therefore, what is your median? 2, 5, 6, sorry? Okay, 6.5. Okay, so the median is 6.5. Okay, so again, this one. So the weight of 7 army recruits are 180, 201, 220, 191, 219, 209, and 186. Find the median. First, you need to arrange it from lowest to highest. Okay, arrange the data in order to select the middle point. So from lowest to highest, so therefore, the middle number is 201. Okay. Next, 6 customers purchased the following number of magazines, 1, 7, 3, 2, 3, 4. Find the median. What's the first procedure? Arrange the given number from lowest to highest. So after you arrange, okay, which is 1 to 7, so 1, 2, 3, 3, 4, 7. So the middle number will be 3 and 3. Okay, 3 and 3, there are two middle numbers. So how do we get the median? We need to get the average of the two middle numbers. So that will be 3 plus 3 over 2, so you do have 3. Okay, can you still follow? Is it easy? Okay, next. What about mode? So when we say mode, the data entry that occurs with the greatest frequency. Okay, the greatest frequency. If no entry is repeated, the data set has no mode. If 2 entry occurs with the same greatest frequency, each entry, we call it bimodal. Okay? So in letter A, so 5.40, 1.10, 0.42, 0.73, 0.48, 1.10. So what is your mode? What is your mode in letter A? Okay, why is it 1.10? Why is it 1.10? Okay, so that will be 1.10. Next, 727. 55, 55, 55, 88, 99. So what is your mode? Okay, 27 and 55. So there are two numbers, okay, that occurs with the greatest frequency. Okay, there are two numbers that occurs with the greatest frequency. Then we call it bimodal. Okay, bimodal. Next, letter C. 1, 2, 3, 6, 7, 8, 9, 10. What's the mode? Okay, none. Why? None. Why is it? Why is it? Okay. No. No numbers that occurs in the greatest frequency. So, it's no mode. Okay. So for example, the following data represent the duration of US Space Shuttle voyage for the years 1992 to 1994. Find the mode. So these are the data set: 8, 9, 9, 14, 8, 8, 10, 7, 6, 9, 7, 8, 10, 14, 11, 8, 14, and 11. So first you need to arrange it from lowest to highest, and then you identify the mode. So the answer is 8. Why is it 8? Why is it 8? Okay. Okay, most frequent, which is 8. How many? How many? 5. What about 9? How many? 3. 10, 2, 11, 2, 14, 3. So the most frequent number is 8. So that's your mode. Okay? So comparing the mean, median, and mode, all three measures describe an average. Choose the one that best represents a typical value in the set. Mean, the most familiar average, a reliable measure because it takes into account every entry of a data set, may be greatly affected by outliers or skew. So we will discuss outliers as we go along. Median, a common average, not as affected by the skew or outliers. Mode may be used if there is an overwhelming repeat number of data entries. Okay? So choosing the best average. So choosing the best average, so we do have skew to the left. Okay? So we have mean, median, and mode. And then symmetric, meaning that mode, mean, and median, they are the same. And then skew to the right positively. Okay, so we do have mode, median, and then mean. So we will dealing with this one. We call it the skewness. Okay, skewness. So the shape of your data and the existing of any outliers may help you to choose the best average. So the best average I think is the symmetric. Okay, if the skewness, meaning your three measures of central tendency are equal, so that is normal distribution. Okay, normal distribution. So mode is equal to the mean, is equal to the median. So we call it skewness. So appropriate measure of central tendency. So we have level of measurement. So we have nominal, ordinal, interval, ratio. Okay. So when we say nominal, you need to use mode. Ordinal, we're using median and then mean. If a smaller observation, we use median. If it's a large observation, we use median and mean. Interval and ratio, okay, without outliers and without outliers. With outliers, we use median. Without outliers, we're using mean. Okay. But how do you differentiate the three? How do you differentiate the three? So when I'm saying nominal scale, this is the most primitive level. The nominal level of measurement is used when we want to distinguish one object from another for identification purposes. Okay? In this level, we can only say that one object is different from the other, but by the amount of difference between them cannot be determined. So in short, in other words, when we say nominal scale, you are referring to gender, nationality, civil status. Okay? You cannot compare between them. Okay? You cannot determine. Because we're talking about categorical. So that's nominal. Okay? So in other words, when we say nominal scale, you're referring to categories. So what are those? Gender, nationality, civil status, what else? What are the example of categories that can be considered nominal scale? Aside from gender, nationality, civil status, what else? What are the example of nominal scale? That the difference between them cannot be determined. What else? Any example of nominal scale? Any example in your mind? Aside from gender, nationality, wherein we cannot, the amount of difference between them cannot be determined. What else? Aside from gender. What else? Hello? Hello? What else? Hello, people? Okay, religion. What else? Okay. What else? There's so many. Ano pa? Okay, strand. Okay, so these are the example of nominal scale. So in other words, I'm saying nominal scale, more on categories. Okay? Ordinal scale, from the word itself, ordinal meaning what? You need to do some ranking. Okay, ranking. So that's ordinal scale. In the ordinal level of measurement, data are arranged in some specified order or rank. Okay? Ordinal scale. From the word itself, ordinal meaning order or rank. Okay? When objects are measured in this level, we can say that one is better or greater than the other. But we cannot tell how much more or how much less of the characteristic of one object has than the other. Okay, so an example of the ordinal scale, ranking of students in a class, siblings in a family, contestants in a beauty pageant. Okay, so that's ordinal scale. In short, when we say ordinal, data are arranged in some specified order or rank. Okay, next, interval scale and ratio scale. In this particular, how do you differentiate the two? What is interval and what is ratio? Can anyone differentiate the two? What is interval and then what is ratio? When we say interval, data are measured in the interval level. We can say not only that one object is greater or less than the other, but we can also simply specify the amount of difference. So the example of this one, suppose Anna got 10 in stat quiz while Bet got 8. So we can say that Anna got higher than Bet by 2 points. So that is interval scale. But what about ratio? What about ratio? Ratio is the same as interval. But there is a restriction. Ratio scale can be the same as interval. You can compare, okay, the amount of difference of the two, but there is a restriction. What is the restriction in this particular? What is the restriction in this particular? Okay, kapag ratio scale, the base is from 0. Okay, 0 going to a particular number. So 0 going to a particular number. So 0 has a bearing if it's a ratio scale. Okay? But if it's interval scale, 0 is not, there's no bearing. Okay, 0 has no bearing in an interval scale. Likewise, if it's a ratio scale, 0 has a bearing. So can you give me an example of a ratio scale that 0 is important? Can anyone give me an example of ratio scale that 0 is important? Weight. Okay. Weight. Why do you say so? Zero meaning. Zero meaning. Okay. Aside from weight, what else? Aside from weight, what else? Ano pa example ng ratio scale? Height, what else? Distance, what else? Sorry? Speed, what else? Can we consider temperature? Okay, yes, why? Why is it? Okay. Okay. So that's an example of ratio scale. Okay. 0 has a bearing. Likewise, in interval scale, 0 has no bearing. Okay. So the example of interval scale, mostly the scores in the examinations.